how we can identify the slope and y-intercept of an equation and also graph equations using that slope-intercept form. And as we're working through this, we're also going to be able to write equations of lines using our slope and intercept form. So you may remember from other math classes that the slope-intercept form for equations of a line is y equals mx plus b, where in this line right here equation, the b represents the y-intercept value. And we're going to write the y-intercept, just like we've learned earlier, as a point. So it's going to be the point 0, comma, and then the value for b in our line. The other thing we're going to do in our slope-intercept form is identify the value for m, which is always going to be in front of the x. And that value for m is our slope. And in order to use it to draw our graph, we're going to use the meaning of slope as rise over run to draw our graph. So what you're going to do is follow along on the notes as we go through this video. And we're going to look at first how we graph equations using our slope-intercept form. And again, we're using the domain all real numbers from negative infinity to infinity. So that's going to tell me to put arrows on my line at both ends as we draw them. So as you're going to try to draw your equations using the slope-intercept form, the first thing you're going to do is look at the equation we give you. And the first thing we should think about is this equation in slope-intercept form? And if it's in slope-intercept form, it should be written as y equals mx plus b. So when I look at this equation right here, y equals 1/3 x plus 1, we can see that, yes, it's written in that format. We have y equals 1/3 x plus 1. So it's in that format of y equals mx plus b. As we look through some other examples, we're going to see that sometimes it's not in that format, so we might need to solve for y, and we'll review that when that happens. So the next thing we're going to do is when we think about our equation is we're going to identify the y-intercept. Again, we're going to look at our value for b. So in this case, if I'm thinking of y equals mx plus b, my b value is 1. So that means that my y-intercept is the point 0, comma 1. So the first thing we're going to do is go ahead and plot that point. So on your notes right now, you should go to your coordinate plane and plot the point 0, 1. So there's my first point. Now we know that in order to draw a line, we need another point so we know exactly how the line's going to be slanted. So the next thing we're going to do is identify our slope. And again, the slope is always going to be in front of the x when it's written in our y equals mx plus b format. So in this case, my slope is going to be the fraction 1/3. And so if I'm thinking of slope as rise over run, what would be the rise and what would be the run? So as we look at this, our rise would be 1 and our run would be 3. So that means as I'm creating my slope triangle, I'm going to go up 1 space and then over to the right 3 to create that slope triangle. So we're going to go from our y-intercept, we're going to go up 1 and over 3. So up 1 over 3. And now it's saying plot 2 more points. Now notice on my coordinate plane here, if I try to go up 1 and over 3 to the right, that means that I would fall off this graph. So sometimes what we can do is reverse that. So right now we went up 1 and then right 3. But we can go ahead and reverse it. So going back to my y-intercept, instead of going 1 up and 3 right, I can reverse both steps. I can go 1 down and 3 left, and it'll still create the same line, just going in the opposite direction there. So I can go back to my y-intercept and go 1 down and 3 left. And now I can still see that all 3 of my points are moving up towards the right, which we know a positive slope is always going to move up to the right. And now I have 3 points, so I can go ahead and connect them. I'm going to use this for my straight edge. So I'm going to connect these three dots. And again, because my domain was negative infinity to infinity, we're going to put on our arrows. Just like the directions say, connect our points with a line using the arrows. Okay, so anytime we're trying to graph using slope-intercept form, the first thing we're going to do is plot our y-intercept, and we're going to find that using our value for b. And then we're going to use our slope and count rise over run from the y-intercept to get some points. Okay, let's look at another example. On example 2, you're going to notice that this uses function notation. So number 2 says f of x equals 4x minus 3. But if you remember from our function unit that y and f of x are the same thing. So even though this says f of x equals 4x minus 3, I can rewrite this and replace f of x with y. So I can go ahead and underneath that write y equals 4x minus 3. So now that I've done that, I can see that it's in my slope-intercept form because once again, I can see it's y equals mx plus b. So when the question says, is this in slope-intercept form? We're going to say yes. So we do not need to solve for y in this case. So now again, we're going to look at our equation and we're going to find our y-intercept first. And our y-intercept again is the value for b. Now notice that we always say y equals mx plus b. And this says y equals 4x minus 3. So we're going to keep that minus sign and treat that 3 as a negative. So my b value is negative 3. So to turn that into the y-intercept point, I'm going to plot the point 0, comma, negative 3 to represent that ordered pair. So go on your coordinate plane right now and plot your point. All right, so we should have that point right there on our y-axis. And now we're going to go ahead and find our slope. So notice my slope in this case is the number in front of the x. So my slope here is 4. Now, normally we think of slope as a fraction. So what would we write this as a fraction if we have a whole number 4? That's right, we would rewrite this as the fraction 4 over 1. So now if I rewrite it in that fraction form, because any integer can be rewritten by dividing it by 1, my rise would be 4 and my run would be 1. And again, it's a positive slope, so this means we would go up 4 and 1 right off of our y-intercept. So from the y-intercept now, we're going to go ahead and plot that rise and run, and we're going to get 2 more points. So back here, I'm going to go rise up 4, run 1. So there's my second point. And now I have room to keep going. So we're going to continue off of this point, unlike the first example. From this point now, I'm going to do the same thing. Go up 4 and then right 1. And now I can see that the bigger this slope here, this slope was 1/3, and my line was kind of not so steep. The bigger the slope, the steeper the line's going to get. So I can see that this line is a lot steeper. It's going uphill faster. I'm going to connect my 3 points and again add arrows to represent my domain from negative infinity to infinity. So let's look at a few more examples to make sure we truly understand what's going on. And as we're doing these examples, we're going to see again a few minor changes. So in this one, we saw the f of x instead of y equals, and we just remembered f of x is equal to y, so we could switch that out. Now notice here in my third example that this equation, if I'm thinking about is it in slope-intercept form, I want to know, does it say y equals mx plus b? And when we look at this equation right here, that negative 2x plus y equals 3, does it say y equals? No. So since it's not in my slope-intercept form, it does not say y equals. We need to solve for y. And remember, if the directions say solve for y, that means we want to rewrite the equation so y is by itself. And that really just means that I want to make it say y equals. Okay, so what we do is we're going to go back over here to our equation and we want to get the y by itself. So in order to do that, I need to zero out this negative 2x. I don't want that negative 2x on that side of the equal sign. And remember, an equation is like a balance. Whatever I do on one side of my equal sign, I have to go and do on the other side. So I want to get rid of that negative 2x. I want to zero it out. So right now I have negative 2x, and in order to zero it out, I would need a plus 2x because negative 2x plus 2x would make 0, and so that term would now disappear. To keep my equation balanced, though, if I'm adding 2x to the left side of my equal sign, I now have to add 2x on the right side of my equal sign. So what's going to happen now is this term's going to zero out. I took negative 2x and added 2x to make 0, and that's going to leave me my positive y, or just y. At that bar, I have my equal to. And then here I have 3 plus 2x. Now, are those like terms? No, they're not like terms, so we cannot combine them. So we're going to put the x term first so that it follows our y equals mx plus b format. So I want that x first. So I'm going to put y equals, it's a positive 2x, so I'm going to just put 2x. And then that was a positive 3, so I'm going to put plus 3. Now is my y by itself? Yeah, now my equation's in that y equals mx plus b format. So now I'm going to use this form of the equation to help me identify my b value, my y-intercept. B value was positive 3. So that means I'm going to plot the point 0, 3. My slope was the m value in front of the x, in this case 2. And again, since it's a whole number, I'm going to make it a fraction by putting it over 1. So my rise is 2, and my run is 1. And now I can go ahead and think about it. It's a positive slope of 2, so that means I would go up to the right. So I'm going to plot my y-intercept, which was at 0, 3. And I'm going to go 2 up and 1 right from that y-intercept. And now I want to get a second point. But again, if I try to go up 2, I'm off the paper. So remember, slope can go completely the opposite way. So to keep the line going in that same path, instead of going 2 up and 1 right, I can reverse them both and go 2 down and 1 left. If I reverse both directions, it's going to stay on that same line. So you can see if I go 2 down, 1 left, I end up here. So I can go 2 down and 1 left to get there. And there's my 3 points. I'm going to connect them using a nice straight edge. And again, slope of 2 is pretty steep. So I have a fairly steep looking line here. And again, I added my arrows. Okay, let's look at one more example. So looking at number 4, I want to know, is this equation negative x minus 2y equals 6, is this in slope-intercept form? And if not, I want you to go ahead and solve for y. All right, so hopefully you recognize this is not in slope-intercept form. Again, it's not in our y equals mx plus b format. So hopefully you said, no, this is not y equals mx plus b form. So we're going to solve for y. I'm going to write my work right here for this. All right, so again, if I want to solve for y, I want to get the y by itself. So the first thing I'm going to do is add 6 to both sides. Sorry, add x to both sides. And if I do that, that's going to zero that out, and I'm going to be left with negative 2y equals that positive x and that positive 6. And again, it still doesn't say y equals. It says negative 2y equals. So in order to get rid of the number in front of my variable, I want to take that negative 2y and make it become 1. We divide by that value. So I'm going to divide everybody by negative 2. Running out of room here, so I'm going to squiggle it up here. So now when I divide this, negative 2 divided by negative 2 is going to leave me 1y, because those will cancel each other out to give me 1. And now when I have x divided by negative 2, remember there's an imaginary 1 in front of our x. So I can rewrite this as negative 1/2 x. I can pull the x off the top of the fraction and put it next to it like that so that I can see the m and the x. And then lastly, I have 6 divided by negative 2. A positive divided by a negative is a negative, so I'm going to put minus, and 6 divided by 2 is 3. And now I can go ahead and draw my graph. So again, my b value is negative 3. So that means I'm going to plot the point 0, negative 3. I'm going to go on my y-axis, down 3 units to make my first point. My slope is in front of my x, so my slope is negative 1/2. And now this we know means that we have a rise and a run. My rise is 1 and my run is 2 because slope is rise over run. But because we have a negative slope, we know a negative slope goes down to the right. So because I have a negative slope, we're going to go 1 down and 2 right. So from my y-intercept, I'm going to go 1 down and 2 right. And I can do that again, and it'll actually surprisingly still fit on this grid. I can go 1 down and 2 right. But notice I could also reverse it. I could go 1 up and 2 left, reverse both directions. And if I go up 1, 2 left, up 1, 2 left, I could go from here up 1, 2 left. And notice I can get points going that way, and my line is still moving down. So I'm going to connect my dots, add my arrows, and there's my lines. All right, so that is as tricky as it's going to get when we have to draw our graphs using y equals mx plus b. So you might need to do a little bit of rearranging to get your equation in that y equals mx plus b format. Earlier this year, we called that function form. Now we're going to call it slope-intercept form. And our y-intercept is that value for b, and we're going to plot it as an ordered pair, 0, comma b. And our slope is the value in front of the x, so that's going to be the value for m, or slope. And we can use rise over run to go ahead and graph the points on our line, starting from our y-intercept, and then using rise over run to get our couple points. All right, now just to wrap things up here, number 5 here, I have some quote unquote tricky slopes and y-intercepts. So I'm going to ask you to try these out, and we're going to check our answers as we finish up this video here. So looking at A, I have f of x equals negative 6x. Remember, we can say instead of f of x, y equals. So what do you think is the value for the y-intercept in this case? We're not adding or subtracting anything. So if you said b equals 0, you're great, and that would mean my y-intercept would be 0, 0, which is my origin. And what would our slope be? That's right. The slope would be the number in front of our x, so it would be negative 6. Or if we're using rise over run, we could write that as negative 6 over 1. All right, look at letter B. What is our y-intercept in this problem? If you said 7, you did great because it's y equals mx plus b. So that would be my b value of 7, which again means I would plot the point 0, comma 7 as my y-intercept. And then what would our slope be? Okay, if you said 1, you are correct. There's always an imaginary coefficient of 1 in front of our variables. So we can say the slope is 1, or again, if you want to write it as a rise and a run, we could put 1 over 1. All right, last one. And then you're going to practice some work that'll be posted for you guys in Google Classroom. So last one here. What do you think is the y-intercept for letter C? All right, again, if you said 0, just like A, you are correct. Again, we're not adding anything after that. So my y-intercept would be 0, which again means I would plot the point 0, 0. And then what would our slope be? Yeah, the slope would be -1. So just like here in letter B, there's an imaginary 1 in front of that x. In between that negative and that x, again, there's still that imaginary 1, but this time it would be a -1. Or if we wanted to write it as rise over run, we could put -1 over 1. Okay, so make sure you're checking Google Classroom to complete the rest of the assignments for today. There's a Go formative to have you practice and a couple IXL activities.